working guidelines are applicable to other substrates. Next. Paper is handled 10 to 20 times throughout the supply chain, and the supply chains is identical irrespective of substrates. So there are so many points where damage can occur, and what we're trying to do here is how to avoid that damage. Nigel, next, please. And what we've produced is a 270-page free best practice reference for the entire supply chain. It's been produced by over 30 international companies and industry organizations working together. It helps answer reducing industry resources and availability of skills. It identifies areas for improving both economic and environmental performance as well as safety. And it applies to all print processes and substrates. Next. This morning, we're going to look at two of the modules, or three of the modules, I should say. We're going to look at the first one, which is about paper characteristics. And then modules 4 and 5 will be about paper handling equipment and techniques. Next. So this year, we've got 2 webinars on issues that can cause performance problems. In April, we had the impact of roll hardness on quality. That has also some impact on today's subject, which is out-of-round rolls and roll handling. Next. And today we have 2 experts on this subject. Both of whom were contributors to the guide, so they're really extremely well qualified. Martin Schorn is a paper industry professional with almost 30 years of experience in technical sales and customer service at UPM Communication Papers. He is Director of Technical Customer Service, leading a European team. He holds a master's degree in wood science and technology and is an active member of WAN-IFRA. Hansjoerg Freund has also worked for 30 years in materials handling. Since 1998, he's worked for Cascade Europe to market hydraulic forklift attachments. His current role is Regional Sales Manager, responsible for Germany, the Nordics, Eastern Europe, and also strategic accounts. So at this point, I would like to hand over to Hansjoerg to start today's session. Thank you.
Okay, thank you, and hello, everybody. So the next slide, please. At the beginning, I would like to show you here examples of a core damage and an out-of-roundness roll. Typical causes of core damage out of roundness are excessive clamping force, wrong clamping position, deformation from being pushed against an object. To prevent this, please ensure correct clamping force settings using the pressure selection valve, correct contact pad friction service, or ideally automated paper roll clamps. I will explain later more about these topics. For now, I hand over to Martin, and thank you. And the next slide, please.
Yes, thanks Hansjoerg and also Nigel for the introduction, and yeah, hello and welcome also from my behalf. Looking at this topic from the paper making perspective, there are reasons why some paper rolls are getting out of round more easily than others during the handling process. Different paper grades can have very different end uses, and for that effect, specific characteristics. The simplest characteristic maybe is to describe a paper by the basis weight per square meter. We have, for example, Bible paper and thin telephone directory papers. They start at 30 gram per square meter or even below. Newsprint then would usually be in the 40 to 45 gram area. Magazine paper usually goes from 48 to 65 up to 100 gram, very much depending on the magazine category. And then if we look at higher ends, then paper for magazine and catalog covers could be above 100 gram. and high-end books, we could end up at, let's say, 150. Basis weights can also be above 250 gram, but then we would already talk of cardboard and not anymore of graphical paper. Therefore, rolls can have very different roll weights as well, which are influencing the handling. The paper surface and finish can be different too, glossy for coated paper and silk or matte with both uncoated and coated paper finishes. Together with the used raw material and their characteristics, the winding hardness of the roll when it leaves the winding station at the mill where the customer rolls are produced could vary from soft to hard. Softer rolls can generally be squeezed and made out of round more easily than hard wound rolls. And also the raw material mix has an influence. How soft a roll might be. The width of a paper roll can influence out of roundness, especially if a small one is not clamped, lifted, and handled correctly in the middle of the roll. Next slide, please. Here you see the typical range of graphical paper grades. It starts on the bottom left with the most basic grade, which is newsprint, and then the relative quality improves from machine finished grades as improved newsprint to magazine grades like supercalanded paper and coated qualities like LWC and MWC. Then on the upper hand right, you have the high-end graphical products, which are basically produced out of chemical pulp and are called wood-free paper. Properties like brightness, gloss, or the print quality are usually improving with the relative quality. And the end users are also very different, as you can see from the examples for each paper grade. In general terms of out of roundness, we see the softer wound rolls and the danger of facing it more in the lower qualities, like with the newsprint, MFS, or SC papers. But each quality needs careful handling and the right approach when clamping them. You can imagine that in areas where a lot of different paper qualities are handled, like at ports or warehouses of commercial printers, the correct handling of each sort can be from us in the paper producing industry. But more on this later during this webinar. Next slide, please. The factor of higher influence on out of roundness is the bulk of the paper sheet. The bulk means that a paper with the same basis weight, but with a higher thickness of the sheet, has a higher bulk, so it's bulkier. It's then usually more compressible and softer when a customer roll is wound on the winder. So if the paper's raw materials is chemical pulp or recycled fiber, this makes a difference too in terms of bulk. Pulp and virgin fibers like thermomechanical pulp are bulkier than recycled fibers. Therefore, the winding of such a roll tends to be softer and more prone to out of roundness when clamping and lifting the roll during transport and handling. But Hansjoerg will tell us more in a minute how the correct clamping techniques are looking like and what is essential in the process. Next slide, please. Can we measure out of roundness? Yes, we can. But to be honest, it's quite complex and time-consuming to do this with the following method. The device you see here is called the spider. The roll which is measured with this device needs to be placed on its side, so not on the roll belly. Then the device is centered in the core, which means it needs to be taken, or the facelet of the roll needs to be taken off to be able to center the device. And then an arm with a measuring device is circling the roll. The measuring device is using a laser to measure the distance from its head to the roll surface, and this can and must be done on several points of the width of the roll to see if it's out of round or not. If the distance is differing during a circle or between the measuring circles, it means that the roll is out of round. As you can imagine, the measurement of a single roll takes already some time, but if you have a wide roll, and for gravure printing presses, the width could be more than 3.5 meters, it takes even longer, and the measuring isn't hazard-free as well, because you will have to stand on a ladder to measure the top of the reel. Next slide, please. An easier way to measure out of roundness at the edges of a roll is to use such a mechanical device as you see on the left-hand side here. This gadget is also placed and centered in the core, but in this case, you can lie the roll on the belly for the measurement. You circle around the roll and adjust the head at one point of the roll to its radius. The spring is then moving with the radius at each point of the circle, and you can read at the end of the circle with a color code if there was any deviation. This is done on both sides of the roll and shows it was out of round at the roll sides and edges, but you can't measure the situation in the middle of the roll, so it's only at the edges. If there is vibration on the winder, I wanted to mention that there is also a way to make a real out of round during the production at the paper mill when producing the customer roll. So you have the winder where the customer rolls are produced, and if there is any vibration on the winding stations, the cores of a roll can start to swing and move, and in the end, the core is not exactly in the middle of it anymore, and the roll has become eccentric. So eccentricity is different to out of roundness, which is happening during the handling. And on the printing press, an eccentric roll would also move and bounce as a wrong-handled one would. Eccentricity doesn't happen often in the paper making process, but we've made the experience that this can happen when producing newsprint rolls from 100% recycled fibers. Some mills are using cores, which are grooved at the core sides to have more stability in the winding process and to counter any vibration on the roll winders. Anywho, so much on this topic from the perspective of a paper engineer. Now over to Hansjoerg. The roll is readily packed. So what do we need to consider when the roll is handled and in transport?
Yeah, thank you, Martin. Now I would like to give you some insights into first the clamping principles and terms and the correct clamping force. Second, the roll handling, and third, roll damages and damage reduction. These are 6 interrelated elements that affect how a paper roll clamp picks up a roll. In the next slides, we follow these elements, how they work together from the load back to the forklift truck. Next slide, please. Oh, this was the next slide. So one more, please. Yeah, when we are talking about roll damages, we need to talk first about some clamping principles and terms, starting with the roll to be picked. One of the most important factors in paper handling is the amount of friction between the paper roll and the contact pad. Friction is the resistance to movement on one surface against another. As the truck's mass lifts the clamp, the friction between the pad surface and the roll surface allows the roll to be lifted with the clamp. Friction force must be greater than the roll weight, or the roll will drop. The more friction there is, the less clamp force is necessary to pick up the roll, reducing the chance of overclamping and damaging the roll. Understanding the friction and its effect on roll slippage is important in determining the right amount of clamp force and choosing the correct contact pads. Typical pad contact surfaces types are, like shown here, steel herringbone, ribbed steel herringbone, and different rubber covered pads. There is a pad for every paper type. So next slide, please. Contact pad friction is directly proportional to clamping force. The ratio of contact pad friction to clamping force is 1:1. So clamping force is the force applied to the roll by the contact pad. The clamp force is spread over the pad area. It's measured in kilonewton or pound force. The amount of clamp force applied to the roll depends on several factors. The size of hydraulic cylinders, the amount of hydraulic pressure being applied to the cylinders, the configuration of the arms and the frame, and the diameter of the roll being handled. Next slide, please. Clamping force factor is the ratio comparing the level of clamping force required to securely handle a load versus the weight of the load. The clamp force factor value changes along with certain factors. These are friction of the pads. A pad with a high coefficient of friction will allow a smaller clamp force factor and less resulting clamp force. And dynamic forces. The higher the dynamic forces, the more clamp force that is required and the higher the clamp force factor value. And also the paper type. Papers have different surface friction values. Some paper, for example, has a waxy surface and less friction. The slicker the surface, the higher the clamping force factor value is required. The clamp force specified may require changes to the equipment, such as the use of special high friction contact pads or dynamic force reduce options, such as an accumulator. Paper rolls are often labeled with the recommended and/or maximum clamping force. Clamping force can be measured or derived. For measuring requires a use of a clamp force indicator. Deriving requires measuring attachment, clamping cylinder pressure, and a chart supplied by the attachment provider. Next slide, please. The hydraulic pressure applied to the attachment's clamping cylinders is the means of developing attachment cylinder force. Attachment cylinder force results in clamping force according to the physical design geometry of the attachment. Units of measure is in PSI and in bars. Next slide, please. The pad pressure is the measure of clamp force per pad per unit area of the contact pad against the roll. Pad pressure represents the distribution of clamping force across the total surface area of the pad. It is useful to track contact pad surface pressure within the context of minimizing damage. Next slide, please. Then we have dynamic forces. Lift trucks operate in various environments that cause dynamic force to act on the paper roll when being handled. These dynamic forces are caused by a wide range of handling situations. For example, hoisting a load from a static condition, stopping the load when a load has been sufficiently lowered, travel over rough terrain, accelerating or decelerating, cornering, collision, impact, and misuse. Next slide, please. All 6 before mentioned factors are influencing the roll handling. We can summarize that the correct clamping force is the key for efficient roll handling. Excessive force can cause roll deformation, out of roundness, and many other damages. Insufficient force can lead to rolls being dropped with serious risk of injury and damage, along with sliding or telescoping. Fundamental steps are establish the initial hydraulic pressure, verify that the hydraulic pressure is adequate, fine-tune the amount of pressure, and perform daily checks. With this, I hand over again to Martin. Thank you. And next slide, please.
Thanks, Hansjoerg. Yes, so we have learned that the clamping force is decisive when handling the rolls. In this example, here you see 2 different roll labels from UPM. Both have the recommended clamping force mentioned down in the right-hand corner. You see the number in the red circle. On the left-hand side, you see a label of a newsprint roll. So this is a sheet with a high bulk. And on the right-hand side, we have a roll of magazine paper where the paper is more dense. This means on the left, a soft wound roll with a lower roll weight, and on the right, a hard wound roll with a higher roll weight. Meaning the newsprint roll is more prone to be out of round and needs to be lifted and handled with a lower clamping force and with a lot of care. Next slide, please. So finally, we have arrived at the printer. And this is the place where we really see for the first time if a roll is out of round or not, because that's when the roll is on the press. If it's out of round, it will start to move, swing, and/or bounce on the press's reel stand, which is visible for the eye. A completely sound roll is hardly visible in its movement. And if you think how wide and fast the biggest presses are, one can easily imagine that a heavy and bouncing roll is causing a lot of stress onto the mechanic and structure of the reel stand. The faster a press is running, the bigger the movement of an out-of-round roll will be, and the bigger the stress will be on the reel stand structure. Decreasing the press speed with a bouncing roll in the reel stand is usually a first measure when trying to print such a roll to not experience web breaks or other disturbances. For this reason, press suppliers are giving some maximum recommendations for roll out of roundness of their fastest presses, which is usually lying between 5 to 7 millimeter in roll radius or 10 to 15 millimeter in the diameter. This doesn't necessarily mean that rolls with a bigger out of roundness level couldn't be printed successfully. Especially smaller reels can sometimes be printed with bigger deviations even. Next slide, please. To summarize, what could be the consequences of out of round rolls for the printer? First of all, an increase in web breaks. you can imagine that a web splice, meaning when changing and joining the outcoming roll with the incoming roll, can fail if the tape of the real splice, which you can see on the picture, doesn't hit the new roll in its full length. This issue arises if the bounce of the roll is happening during the moment of the splice. We have a video for that later, which we try to show you. Web breaks can also happen outside of the splicing circle if the web movement is too strong. And as said, decreasing the speed of the printing press might help, but this would be affecting the press efficiency negatively. Last but not least, there will be wear and tear on the press, especially on bearings and shafts, but also on the web tension system and drive mechanisms of the press. Next slide, please. So having to deal with out of roundness can be an expensive exercise for all parties involved, right, Hansjoerg?
Yeah, that is true. And for this, it's really important that before we start a shift, we have to, let's say, respect a couple of things. So it's essential that before every shift, the truck, but also the attachment gets closely checked. Check the general condition of the clamp. It should be clean and free of sharp edges, as well as the clamping force should be checked in details. Look for oil leaks and listen for air leaks. Check equipment conditions, like you can see here on the left-hand image. Check and note the clamp pressure prior to each shift, and check the contact pads. Clean the surface regularly, replace pads when they are too worn. Next slide, please. Yeah, let us talk about roll handling techniques. Basic safety rules and regulations must be always observed for roll handling. On the safety rules, persons must not ride on the load or the clamp. No reaching through the mast and no standing under load. For the center of gravity, the center of the paper roll should be positioned close to the center of rotation. This will reduce torque requirements and increase truck stability. Other roll handling basics: position the truck parallel to and center to the roll, and the lift mast is not tilted. Adjust the short arm for roll diameter and drive forward to touch the roll with the short arm, then clamp with the long arm. Raise the clamp about 30 centimeters and tilt the mast about 3 to 4 degrees. Before lowering the roll to the floor, ensure that the mast is vertically positioned. Avoid centerline clamping and position pads on centerline of the roll. Next slide, please. Yeah, for earlier described damages, there exist suitable damage reduction systems. As hydraulic pressure increases, so does clamping force. Controlling hydraulic pressure is necessary to prevent excessive clamp force on the paper roll. Following solutions are typically available. First and most simple is the manual solution. A typical manual system is the 3-position pressure regulator, with 3 relief settings plus a 4th setting that provides full truck pressure. This valve allows the driver to move a handle that changes the pressure to a preset pressure value. Optional is a light bar that indicates the active setting on the 3-position pressure regulator. Second and more automated is the hydraulic solution. Like the HFC, hydraulic force control, is a hydraulically controlled automatic clamp force system that changes clamp force proportional to the load weight. HFC pressure source is the actual pressure within the mast cylinder. Pressure supplied to the attachment is passively derived from hoist pressure available and manual valving adjustments. The third solution is a fully automatic solution. The fully electronic computer-controlled AFC system actively monitors lift cylinder hydraulic pressure and calculates the appropriate clamp cylinder hydraulic pressure required. A no-slip start pressure is applied initially when the load is first clamped. The final required clamp force is then applied proportional to the weight of the load being lifted. AFC pressure source is the truck pump. With this, I give back to Martin, and I think you will show us some interesting things now, right?
Yes, thanks, Hansjoerg. To make the topic more visible and illustrative, we want to show you 2 short video clips of out-of-round rolls. So, Ingi, if you could maybe start with the first one. Here you see a roll in the reels. Oh, sorry, that's the other one, which I wasn't expecting. So this is showing the running web of a roll, and you can see it's bouncing, and the web is moving a lot. So here you can easily imagine that the web can also break during the printing of the roll. It's not on this video, but it can happen. And if you show the other video, this one, yes, here you see a roll in the reel stand from the side, and this is the splicing circle. So the new roll is accelerated, and you can see it's moving and bouncing. And then the web splice is happening, and because you have this out of roundness, if you show it again a second time, you can see that the web splice isn't successful. So the web is breaking. That's what you can just see at the end here. So the web splice is not happening. So that are two examples of out of roundness, and you can easily imagine that this could be quite disturbing in the efficiency of a press room, and so expensive for any party involved. Nigel, your turn.
Okay. Well, thank you, Martin and Hansjoerg. That was extremely edifying. That in such a short time you've covered the essentials of the subject of out of round rolls and how to handle them better. For those of you who would like more details, you can find them in the guide. And I think the important thing here is prevention when it's possible. So we have an opportunity now for any of you to ask questions. So we can go to the next slide, please, Ingi. Hello. Okay. So I'd like to start off with something which I've always been a bit confused by, Martin. How do you distinguish between out of roundness and eccentricity of a roll?
Yeah, it's maybe it's not easy for the unused eye, but actually you're able to see that on the reel stand, because as you've seen, out of round roll will have pretty much this kind of movement. So it's like one bounce.
Yeah.
And if you have an eccentric reel, because the core is not in the middle of the roll, it would be looking like this when it moves on the reel stand. So that's a quite different movement. And from that point of view, when we from the paper industry are standing at the reel stand to follow the rolls, we could distinguish, is it a handling issue, or has it already happened at the paper mill during the production?
Okay, so eccentricity is more of a problem at the mill, or is it something happening? It doesn't happen in the transport cycle.
No, on the transport you can squash the core as we've seen on the one picture, but if it's in the middle of the core, then in the middle of the row, then it stays there as well.
Okay. Hansjoerg, you mentioned different types of intelligent clamping systems. Are they very expensive to add to a standard roll truck?
Yeah, I would say compared to the value of the clamp, it's let's say a fairly reasonable add-on amount as an option. And I would say, of course, it costs a couple of €1,000 probably, also with the installation and the settings, etc. But if you imagine the cost savings you have without to prevent roll damages, I would say the return of investment is coming very, very quick. So I would say yes, it costs something, but it's a very reasonable price, and there are reasonable priced solutions. For example, if you have just a valve setting, it's fairly cheap. So I would say when you see the overall cost of handling equipment, it's not too much, and again, the return of investment is really very efficient.
Okay. Does that suggest that if I'm handling lots of different substrates, if I'm, for example, a magazine printer, where I'm going to have a greater variety of hardness of rolls and grades of paper, that an automatic solution is going to help the efficiency of handling paper?
Yeah, I would say then an automated system is really recommended. I would say these manual systems we are using when it's not so many different paper types, when it's let's say also more overseeable for the driver. He knows that he has a few kind of different papers, and he can then easily judge. But then if you have more variety, then automated system is definitely the better solution.
Okay. Martin, are any press rooms, to your knowledge, checking out of roundness of rolls regularly, or is this just an occasional basis that they work
I would say it's more exceptional, because as you've seen in the presentation, to manually check it, it's a lot of work and time consuming. But I know of very few press rooms in the UK, for example. They have an automatic unpacking device and also reel preparation device. And during reel preparation, when the reel is turned, they can measure if a roll is out of round. And in that case, they also reject those rolls which are above the tolerance they are having.
Fine.
But usually not.
Okay. And one of the things I was curious about, Hansjoerg, is if you come across out of roundness in your application, where would you start to look for corrective action if you think it's coming from the handling side?
Yeah, when you have identified that it's definitely coming from the whole roll handling and the equipment, I think it's the best if you as a customer get in contact with the truck manufacturer and the attachment supplier, and together you have a look if let's say the settings are correct, and as described earlier, there is all these elements that affect how the roll is being handled on the attachment, and so together you can identify where the problem source is born in originally. So take these people, look to the application, and then we can go step after step through the process, and we see what has to be corrected. And I would say quite often you find a good solution very quickly if you understand what is not correct, and then you can solve the problem together in this team.
Okay, I have another question for you, which is coming from one of our assistants in the audience. Are plastic or aluminium rolls more sensitive to becoming out of round compared to paper? And that's an interesting question.
Yes. Hansjoerg, have you any experience as a clamp review?
Yeah, I would say I cannot remember that we had an issue with other materials. I would say most of the cases definitely we have with the paper, but I cannot recall that we have really issues with plastic materials or others. And usually, you know, when we have other materials, we strongly recommend anyway to do, let's say, a test with a test clamp before. So what we offer in this situation is that we provide an attachment, a paper roll clamp in whatever size, and then we can test on site how it works with the certain material. And also about the friction. Then we have to test how does it work with a certain contact pad surface. And again, here a lot of elements work together. And as you mentioned earlier, I have so many years in the industry, but we are still learning. new materials are coming up, and the best is always to perform a test, a demo with a suitable truck and a suitable attachment, and then I think you can prevent problems straight from the beginning of the process. But as said, I cannot recall that we had with other materials we had out of roundness problems.
Okay, that reminds me of another question, which is certain paper makers, and I'm thinking particularly in Asia, would wrap their paper in plastic rather than the standardized paper wrapping that we're used to. And I was in a printer in Melbourne who had all sorts of problems with paper dropping through clamps, and this was directory paper, so it was extremely sensitive. So Martin and Hansjoerg, do you have any anything to say on plastic wrapped paper rolls?
Yeah, we had that when I started in the company in 1996. We also had one paper mill in Finland who was using plastic wraps for some of the rolls. I guess Hansjoerg can say more about the friction, which is definitely different with plastic than with the board, which you usually have around the roll. But in terms of sustainability, you hardly find that anymore, at least with the European paper suppliers. UPM doesn't have any paper mill or paper machine where we wrap with plastics nowadays. But Hansjoerg, maybe you can say more.
Yeah, I think I can confirm that. But let's say in the cases where you have other wrappings, then again, like we said in the webinar, we have the different contact pad surfaces, and again, best is to test also in the environment where the paper is handled, and then you see if it sticks on the contact pad, yes or no. But generally, I think this you can solve the problem with the right contact pad. And again, here best is to test it. When we do these tests, we have certain contact pads available, and then we can see how it works. But as Martin said, mostly is with the paper wrapped here in Europe, and that is our experience as well.
Okay. Inge, if we can move to the last slide, please, and then we can conclude this morning. So I would like to thank both Hansjoerg and Martin for a really excellent webinar. I think it brings us all up to date on how we can deal with problems which are always there. This has been in the industry for as long as I have, and you don't really want to know how long I've been in the industry for. And this is one of the reasons why we produce the guide. The guide is to share, to collect, structure and share ways where we can work better. And the 5 steps to optimize your paper handling, we summarize here. Start with downloading your free ebook, share it with your colleagues, identify areas for action, use key performance data to monitor improvements if you've got a significant issue, and enroll for free best practice webinars. Come back and see us again. Collaborative best practices improve performance. We hope that today has been an interesting one for you, and we look forward to being with you again in the future. So from the team today, I would like to thank you for your time and to wish you a very good day. Bye.
Thank you.
Bye-bye.
Thank you very much. Bye-bye.
Bye-bye.